Another part of the model that looks at optimality, trying to figure out what's the optimal consumption bundle for an individual, is the indifference curve. The budget constraint is the part that constrains us. The indifference curve tells us what are your preferences, or in other words, how much of each good are you willing to consume and just basically be indifferent between. So let's take a look at what an indifference curve, or how an indifference curve can be drawn. And what we're going to do is we're going to look at two goods, good 2 and good 1. So x1 and x2, those are our two goods. And an indifference curve would simply say, well, if I have a lot of x1 and a little bit of x2, that's fine. And if I have a lot of x2 and a little bit of x1, that's fine. And if those two consumption bundles make you equally happy, they'll fall on a single indifference curve. Now, typically, indifference curves look like this. I'm just going to label that indifference curve 1, or IC1. This is the typical look of an indifference curve. And again, it basically says this. If I have this amount of x1, which is a lot, and this amount of x2, which doesn't seem like a whole lot, and you were to give me more of x2, I'm going to have to give up some of x1. In order to keep myself on this indifference curve, there have to be trade-offs made. And any point on the indifference curve makes me equally happy. And that's the key to understanding an indifference curve. The combinations of goods, x1 and x2. So here's just another combination. But this combination, this second combination, this one here, that makes me equally happy as the first. I'm just as well off. In other words, I am indifferent between these two combinations of goods. They make me just as happy. Now, I said you can't consume more of both goods just a minute ago, and the reason you can't consume more of both goods is because of one of the assumptions that we make about indifference curves. It's really important to understand the assumptions about the indifference curve model. And one of those assumptions is that more is preferred to less. At least for goods that are normal, more is preferred to less goods that are goods. You'd prefer to have more of x1 and x2 together, but if you had more of both, that would make you happier, and that would move you off of this indifference curve. Which gets us to our second assumption about indifference curves, and that is that indifference curves basically go on forever. There are an infinite number of indifference curves. So indifference curve mapping, we can just say is infinite. I've got indifference curve 1 here, but I can easily draw indifference curve 2 right here, and that would be a preferred indifference curve. And I can draw one that's just a millimeter away from this one, and a millimeter away from this one, and progressively fill the board with all kinds of indifference curves. Indifference curve mapping, in other words, is infinite. There can be, well, an infinity number, or billions and trillions and gazillions of indifference curves. That's our second assumption. So more is preferred to less. Indifference curve mapping is infinite. A third assumption that we make about indifference curves is that they do not cross. Indifference curves don't cross. Let's see what happens if the lines do cross. What's the problem here? Well, here we have a set of indifference curves that cross. And where they cross, we have a point. Now let's say we have this. We have A, and A is preferred to B. So we want A rather than B. And B is preferred to C. So we should be able to assume that C that A is preferred to C. Well, the problem here is that A and C lie on the same indifference curve. So A can't be preferred to C if it's on the same indifference curve. Similarly, B and C lie on the same indifference curve, and so really B and C can't be compared either as one being preferred to the other. So if the lines cross, what we find ourselves facing is that this law of transitivity gets violated, where something can be, where we think something can be preferred, it can't be preferred anymore because the lines cross. Indifference curves are all about being indifferent as long as you're on the same curve. So we have more is preferred to less, indifference curve mapping is infinite, the lines don't cross, and that leads us to a fourth assumption about indifference curves, which is this. A higher curve is preferred. A higher indifference curve is preferred. And what do we mean by higher? Well, typically we mean moving to the northeast. As our indifference curve mapping, this infinite mapping, progresses, we see that there's more and more indifference curves, and they always move up in this direction. The best indifference curve for you, the one that you are able to get on, is the one that's furthest up to the northeast. So everything on indifference curve 2 is preferred to indifference curve 1. Everything on indifference curve 3 is preferred to indifference curve 2. So those are our assumptions about indifference curves. Now, indifference curves also have another component to them. And it is centered around, or it's based upon the slope of the indifference curve. Let me get a new indifference curve up here so we can see this a little bit more clearly. When we look at indifference curves can take different slopes. And those slopes do tell us a lot about the goods themselves. For example, if we had an indifference curve that looked like this, a straight line, that would reflect that the goods themselves are really good substitutes for each other. The slope of this line, the rise over the run, or delta y and delta x, so the slope is equal to delta y over delta x, that's telling us, if the line is straight, that the slope is always constant, and you always know what the trade-off is between these two goods. They're pretty close substitutes in that case. But, as we saw, the previous indifference curves were not straight. So what does that mean? Well, it just simply means this. If you have a normal-looking indifference curve, call that indifference curve 1, and the line isn't straight, it means that the slope isn't the same, and it means that the trade-off between the two goods is not the same all the time. Up here, for example, we'll call this point A. In order for you to make a trade-off between x1 and x2, let's say we move from point A to point B, well, the delta y is really big. The delta y compared to the delta x is really big. And the slope here is really steep. But if we're over here, and we'll call this point C and point D, in order to get you to trade off down here, the delta y is pretty tiny, but the delta x is pretty big. So what's going on? Well, it's pretty simple. At different spots on the indifference curve, it requires more of one good to get just a little bit of the other. Or it takes a lot of one good to get a little bit of the other. Or you give up a little bit to get a lot. The slopes are not constant. Now the slope of an indifference curve is sometimes called the marginal rate of substitution. And it's that marginal rate of substitution, or the slope of the indifference curve, that gives us an indication about how much you value one good over another. In order to keep myself here, in order to keep myself indifferent, and I don't have a whole lot of y to start with, I'll give up a little y. I'll give you a little bit of y, but you've got to give me a lot of x in return. Why? Well, because I don't have very much to start with. Up here I have a lot of y. If you want me to give up some of my x, which I don't have a lot of, well, I'm going to give up a little bit, but you've got to give me a whole lot of y in return to keep me indifferent between point B and point A. That marginal rate of substitution, or the slope of the indifference curve, is something that we're going to need, we're going to have to be paying very close attention to when we try to optimize our condition. In other words, when we try to find the optimal amount of goods x and y to consume, we need to know the marginal rate of substitution.